In this next set of videos, we will be discussing the idea of a normal distribution and why it is so popular, why it is so interesting, and why basically it makes our life much easier. Okay? And to keep the narrative of the story, of the school story, we've come to the third question. Here, the principal is starting to ask about probabilities, right? Probability that the student gets a distinction, probability that the student fails in science, all right? And remember our basic problem. The basic problem is that we're dealing with a sample, and from the sample, we have to make conclusions on the population. Okay, so we cannot just take a ratio. Some students ask me, okay, no problem, take the ratio of students who passed over the entire number of students who passed over the total number of students, and you get the probability or the ratio. Well, that doesn't make sense, because you're assuming that the whole sample is the population, which is not the case. The sample is a slice of the population, all right? And the normal distribution will help us go around this problem, all right? As you'll see, we will assume that our population is normally distributed, and from this assumption, we will be able to come up with some interesting answers. But you might tell me, but what the heck is this normal distribution? So it's time to answer that question. So let's go. So we've already seen so far some pictures. When I plotted the histogram, all right, let's open the whiteboard where I have the other lesson. Okay, so let's move to this lesson. So we have already seen some pictures of histograms, right? And now our job is to try to make some sense of how close they are to a normal distribution. But first of all, what is a normal distribution? Unfortunately, my graphical skills are not the best, but if I take you on this picture here, all right, you will see that one word jumps out of the board when you see this picture: symmetry. All right, I have the middle, the dead middle, which is 0, and I have symmetry. The area under the graph on the right-hand side is equal to the area on the left-hand side. All right, on the y-axis, we usually put x or z, as we'll see later on. And on the x-axis, we put x or z. I will explain what z is later on. And on the y-axis, we put the probabilities. Okay, so here, the interpretation of this would be, what is the probability that I get a 0? And it would be around 0.4 something here. All right, but that's a point probability, which means at a single value. All right, that's one way to look at it, but it's not a good way to look at it. The best way to look at it is as a cumulative probability. All right, it doesn't make sense to say what the probability of getting a 0 here. Basically, what makes real sense is to ask, what is the probability that I get 0 or less, or 1 or less, or -1 or less? Okay, and this question of probability is answered by the area under the graph. It's a very important principle, write it down. The area under the graph gives you the cumulative probability. So, for example, the area of getting 0 or less is this area from 0 to the left-hand side. Okay, but for now, I don't even want to get too much into this concept of probability. For now, we are just inspecting shapes. So you can even forget what I said about probability. Let's just look at the shape. And the shape here is perfect symmetry. Is it always like that? The answer is no. No, all right? So let me go back to the board. When you have perfect symmetry, as I said, 50% of the area is to the right-hand side, and 50% of the area is on the left-hand side. And in this case, and only in this case, do we have a situation where the mean is exactly equal to the median. All right, only in this case. But as I said, this is not the only shape, because we've seen from our histograms that we had some other types of shapes. What if you have something like this? You have an early peak, it peaks early, and then it tails off. In fact, we call this a tail. It tails off to the positive, or in the positive x-axis, to the positive side. All right? It tails off to the positive side. We call this positive skewness, because as I said, the tail is going on to the right-hand side, to the positive side. And when you have such a situation, this is not a normal distribution. Why? Because the mean is not equal to the median. In fact, when you have such a situation, the mean is greater than the median. All right, so when the mean is greater than the median, we have that, we have a positive skewness. What if we have the other way around? What if we have a late peak and the tail is moving towards the negative side? See, the peak is here and the tail is on the left-hand side of the peak. So it's moving in the negative direction. And yes, you guessed it, it's the other way around. It's called negative skewness. And in this case, the mean is less than the median. All right. And again, this is not a normal distribution. Okay. So what is a normal distribution? It is a graph with numbers and probability, and you have perfect symmetry. 50% of your data has a probability of falling on the left-hand side of the mean. 50% of the data has a probability of 50% of falling on the right-hand side of the mean, or of the median, because they are equal. Okay, so I repeat, because this is the crux of everything. 50% of my data is on the left-hand side of the mean in a normal distribution. 50% of my data is on the right-hand side of my mean when you have a normal distribution. We cannot say the same for the other two cases. Now, let's have a quick look at our data. First of all, look at final, the histogram for the final. We have an early peak, and then the tail moves towards the positive side. So, pause the video here. What do you think? The kind of skewness that we have here? It's a positive skewness, so we should expect the mean to be bigger than the median. Let's check it out. All right, this is the mean that we had before, and look at the median. The mean is greater than the median because we have positive skewness. What about English? Look at English. We have the mean here is less than the median for English, right? So we expect negative skewness. Let's see if that is the case. I go down to English, and that's exactly what I get. Imagine starting to form a graph, a curve, passing from here. You would get something like this, right? Remember what was the problem here? We had this tail, this outlier, right? We had an outlier here. So it's making our data negatively skewed. If I removed this outlier and I just focus on this batch, it would very much look like like a normal distribution if I remove this. Okay, so this is causing the problem. What about maths? They look pretty bunched up in the middle with no left tail or right tail. So we should expect here the mean and the median to be pretty close to each other. All right, let's see. And that's exactly the case. They're pretty close to each other. All right, with science is a bit different. I know that the mean and the median are pretty close to each other, but then the histogram is a mess. All right, so we cannot say that just because they are close, this is normal distribution, right? Because there's no symmetry at all here. So be careful about saying that something is normal distribution. This is just a visual test. We call it by inspection, right? There are more sophisticated tests, which we'll not cover in this short course, but this is quite indicative of the point I'm trying to make. All right, so I think we now have a good picture of what the normal distribution is. In the next video, I'm going to start working with the normal distribution to find probabilities.